For decades, the walking, working humanoid robot was pure science fiction. Not anymore. In 2026, they are stepping off the screen and onto real factory floors, and the race to build a mechanical workforce has quietly become one of the biggest contests on Earth. Imagine a worker you don't hire, but purchase. One that never sleeps, never quits, and costs less each year. Everyone from Tesla to a wave of Chinese startups is racing to build exactly that. And when you look at who's really ahead, the answer is surprising. And it is not a demo reel anymore. America's Figure, founded only in 2022 by entrepreneur Brett Adcock, has already put its humanoids inside a BMW plant where they help build real cars. China's Unitree is shipping thousands. The machines have crossed the line from promise to product. The dream itself isn't new. Back in 1992, an MIT spin-off called Boston Dynamics began teaching machines to walk, run, and balance decades ahead of everyone else. But it built jaw-dropping demos, not affordable products. Turning that magic into a machine you can actually buy is the race happening right now. So who is actually building them? The pioneer is Boston Dynamics, an MIT spin-off from 1992 that spent decades teaching machines to walk. The challenger is Figure, an American startup founded in 2022. And the champion of cheap, mass-produced robots is China's Unitree, founded in 2016. An old dream, a brand new race. And the numbers are exploding. In 2025, a few thousand humanoids shipped worldwide. In 2026, that could leap past 50,000, a 700% jump in a single year. This is the steepest curve in modern technology, and they are getting shockingly cheap. China's Unitree sells a full humanoid for around $13,000 and a smaller one for under $6,000. What used to cost as much as a house now costs less than a used car. Price is collapsing and demand is following. Now a reality check. Today's humanoids are still clumsy. They walk carefully, tire quickly, and fumble delicate tasks a toddler could manage. But so did the first cars and the first phones. What matters is not where they are, but how fast they are improving, and that speed is breathtaking. In America, Tesla is betting biggest of all. Its robot, Optimus, is being built first to work inside Tesla's own factories, with a wild dream of one day making $10 million a year. If it works, Tesla becomes not just a car maker, but a maker of workers. China's answer is a national campaign. Beijing has set a target of 100,000 humanoid robots in a single year and already makes around 90% of the world's supply. It is the same all-in playbook that won it batteries and solar, aimed now at robots. But here's what almost no one says out loud. A humanoid robot is not one technology. It is three, fused into a single body, a brain of computer chips, a heart of batteries, and muscles of rare earth magnets. It is every war this channel has ever told, standing on two legs. Start with the brain. This is where America leads. The artificial intelligence that lets a robot see, balance, and learn runs on advanced chips and on software from NVIDIA, Tesla, and a cluster of brilliant startups. In raw intelligence, the West is still ahead. In the heart, every step, every lift, every hour of work drains a battery pack buried in the robot's torso. And the best, cheapest batteries on Earth, as we've seen, come overwhelmingly from China. The robot's very stamina depends on Beijing. Now the muscles. To move like a human, a robot needs dozens of tiny, ferociously strong motors called actuators. And those actuators depend on rare earth magnets, neodymium, and its cousins, the exact metals China spent decades cornering. This is the twist that changes everything. In a humanoid robot, the intelligence, the sensors, and the software make up only around 14% of the cost. The moving body, the motors, gears, and magnets is roughly 70%. A robot is mostly a hardware problem, and hardware is China's home turf. Look at who controls those magnets. China refines around 90% of the world's rare earth magnets, the beating muscle of every humanoid. Japan holds a sliver, Europe and America almost nothing. Whoever owns the magnet owns the motion. So two very different bets are taking shape. America is betting on the mind. Tesla, Figure, and startups like 1X are building their own motors and brains in-house, wagering that the smartest robot wins and that clever design can beat cheap parts. China is betting on the body. Unitree, founded in 2016 by a young engineer named Wang Xingxing, along with UB Tech and a swarm of rivals, is mass-producing robots the way China mass-produces everything: fast, cheap, and at enormous scale. On a supply chain of magnets and motors, it already dominates. China holds one more hidden edge: data. Every robot working in a real Chinese factory sends back a flood of real-world experience, teaching the next generation to move better. The more robots China deploys, the faster all of its robots learn. It is a flywheel already spinning up. And here is America's quiet weakness. It can design the finest artificial mind on Earth, but it barely makes the humble actuator, the motor in the joint. That unglamorous part is where the real cost and the real dependence on China actually lies. It has already produced a strange marriage. In 2026, America's NVIDIA and China's Unitree unveiled a robot together, the strongest American brain inside the strongest Chinese body. Even as the two nations fight, their robots are being built hand in hand. The West knows the danger. Startups like Nion are racing to build magnets with no rare earths at all. Others are recycling old motors for their metals. It's real and it's clever, but it is years behind the machine China has already built. Step back and the stakes are staggering. A cheap, capable humanoid is not just a gadget. It is a workforce you can manufacture. It could reshape factories, warehouses, elder care, and eventually our homes, the biggest shift in human labor since the machine age began. The first jobs won't be glamorous. They'll be the dull, dirty, and dangerous ones, moving boxes in warehouses, bolting parts on assembly lines. But every year the robots get cheaper and smarter, and the circle of what they can do quietly widens. China already runs what it calls dark factories, plants so automated the lights can be switched off because no humans are inside. Fill those with cheap humanoids, and you get a factory that builds products and even builds more robots almost entirely on its own. That is the end game everyone is quietly racing toward. And beneath the geopolitics sits a human question. If a robot can be bought to do your job, cheaper than you, what happens to work itself? Some see abundance and freedom. Others see disruption on a scale we are nowhere near ready for. That debate is only just beginning. The money agrees. One Wall Street bank sees a $38 billion market by 2035. Another sees $5 trillion by 2050, a prize the size of a national economy. Whoever leads humanoid robots may lead the entire next era of work. So who wins? If the robot were mostly a brain, America would be cruising. But it isn't. It is mostly a body, and the body runs on Chinese magnets, Chinese motors, and Chinese scale. The smartest robot in the world still has to be built, and China builds. And if this feels familiar, it should. Chips, batteries, solar, rare earths, every story we've told converges here in one walking machine. The robot is the final exam of the industrial age, and on current form, one country is set up to ace it. So who wins the robot war? America may keep the smartest mind, but China holds the body, the magnets, and the factories, 70% of the machine. Unless the West rebuilds its hardware, the age of the robot may be built quietly in China. Next time on Future F-Frame, the other giant devouring the world's chips, the trillion-dollar race to build the data centers behind artificial intelligence. Subscribe so you don't miss it.